Okay, next we're going to talk about circular motion of electrons. We know this formula, which we've discussed throughout all of our videos, F equals QVB. So now we also know Mr. Hessler's favorite formula. But first we need to know his favorite number, his favorite color, and his favorite formula, which is so now we know Mr. Hessler's favorite formula of mv squared over r. Because they're both forces, we can set them equal to each other. So it's QVB equals mv squared over r. So we can cancel out a v, and we want to solve for r. So r equals mv over qb. Now that we've solved for the radius of the path of the electron, we can use that value to solve for the period, the frequency, and the angular velocity. So first let's solve for the time. We know the period of a circular motion, an object in circular motion, is 2 pi r over v. So now we can use this r that we got over here and plug it into that equation. So this goes in for here. So it's t equals 2 pi times mv over qb divided by v. So we can move the qb to the bottom. So we're left with t equals 2 pi mv over qvb. We can cancel out the v's here. So we're left with 2 pi m over qb. So now that we have the time, we can use the period to solve for frequency. So we know frequency equals 1 over the period. So we have to invert this right here. So we're left with qb over 2 pi m. And there's our frequency. Now that we have the frequency, we can solve for the angular velocity. So we know that formula to be omega equals 2 pi f. So we plug in this with f, and we're left with 2 pi times qb over 2 pi m. The 2 pi's cancel out, so we're left with omega equals qb over m. So now, just by using an equation that we learned last year, and one that we just recently learned, we're able to solve for the radius of the path of the electron. And using the radius, we were able to solve for the period, the frequency, and the angular velocity.